Hello, I'm Astronaut Alec, and today I'll be showing you how to do a flow simulation in Solidworks. Today we'll be simulating a sphere. So the first thing we're going to do is start a sketch in the front plane. We'll pull a round circle into the object drawing menu. We'll make it a diameter of 3 inches, so something like a golf ball. And then we're going to cut it right in half. And then the first thing we'll do is use our trim tool and trim off one of the sides. Then we'll be able to use this revolve base button right up there in the top left. And if we revolve that half circle around 360, we'll get our sphere. Then we'll have the flow simulation, which can also be accessed through if you go to the tools, go to add-ins, and you will have to check the Solidworks Flow Simulation 2018 or whatever year you're doing. So I already have that. So we got our sphere. So then we'll want to go to the Flow Simulation button here, press Wizard, and it says that we need to save the documentation. So we'll just name it Vol. And then we'll be able to use the wizard. So we'll hit the wizard button, and it'll pull up a menu that will allow us to easily simulate this object. So we'll just come up with a name, sphere test, and you'll be able to hit next. Then you're going to want to choose your system of measurement. We're going to choose external, and you'll want to check both of these boxes. And we'll just press next. Don't worry about that bottom stuff. Up here we're going to want to select gases and then air, and then you can change this flow type, but we'll just use laminar and turbulent for now. Then this one we can just skip, and then in here is the one important part you'll want to check: which direction your wind's coming from. So in this one we'll just want it to come from Z, and we'll do 5 meters a second. And then we'll hit finished, and that'll generate this box around our object where it will be calculating our flow simulation. Then we'll want to go to our mesh, right click on it, hit edit definitions, and we can choose our level of mesh, and I can show you what the difference is. So as we increase the mesh level, you'll get a more exact simulation, but it'll take longer for your computer to run it. So to make this video fast, we're going to just use the level 3, and this lower one will allow you to increase the density of cells right by your object. So I usually like to increase that to about 2. And then from here we'll be able to select our goals. So you'll want to insert global goals, and we can increase this side window so we can see this better. And we'll probably want to know the velocity of the air, so we'll do max, average, min in all 3 directions. And then the pressure, and then we'll want to know the normal force. So we'll go to normal force, select those 3. Usually those are the most interesting ones. And once we have all that, if you want to change the computational domain, you'll right click on that, hit edit definition, and you can pull these out or push them in to change that. If you make it tighter on your shape, it'll make it quicker. But at this point I feel pretty ready to run it. So we'll hit this play button at the top, and that'll run the simulation. And you'll want to hit run, make sure you use all your cores, new calculation. And then we should see another window pop up where it will be calculating all of this. So that's right here. So first it generates the mesh, and then it starts calculating. Alright, at this point we can see at the bottom of our screen it says the solver is finished. So we'll be able to exit out of this, and we will want to hide our computational domain. So you'll just want to right click on that, hit hide. And on our results we'll have a lot of ways to demonstrate how we have simulated the flow. So the first thing we'll want to do is the cut plot, which will cut a section out and show us the flow in there. What I'm interested in is the pressure. So we'll increase this just to get a better visualization. And that'll calculate the pressure. And then you'll just want to right click on that and click play. So it'll show us how the pressure varies around the object in our computational domain. So we can see it goes back there, and then behind it we have some, so this is the front. So we'll have the high pressure up front, you go behind it, and there's low pressure. So then that's one way of showing it. The second way is the surface plot. So you just select a surface and it'll display the results right on the surface. So we can see high pressure on one side, low pressure on the other. Then we can do iso surfaces, which are pretty cool. Hopefully this will turn out pretty well. We can see that there's pressure in front and behind. It doesn't really demonstrate the difference in it, but kind of demonstrates the visualization of the pressure fields. Then we can do flow trajectories, which is my personal favorite. So what you'll want to do is hit flow trajectories, pull this drop down arrow, select a plane, and then you'll have an arrow on the plane that you can slide forward or backwards or any direction. And then you'll just want to increase the number of points. So we'll do 50 points. And then you can select the object that you want. Oh, no. Yeah, we can just select the object we want, and then it'll select 50 points and simulate their flow around it. And the cool thing you can do is hit play on that, and that'll kind of show you what's going on. Looks like there's a turbulent zone back there, and then the air coming in from the front. And those are our best simulations of the visuals of it. Then we can hit goal plots, insert, and if we click all, we can see the statistics show up on the bottom of all of our values. So the Z normal force would be our drag, which is 0.01. The Y normal force would be our lift, and the X force would be the torque, I believe, but you'd have to check on that. It's very little, so not too sure what that's getting generated by, but this is how you simulate an object in Solidworks. Please make sure to leave a like and subscribe. Everyone have a great night.